This is the lecture video for section 7.5. This is the second video. Here we're going to talking about dot product. We're going to talking about first the IJ form for vector, second dot product and some examples, and then third properties of dot product. When we first talking about vectors, we're talking about we can graph the vector by draw a ray from the initial point to the terminal point. Second, we're also talking about we can write vector in terms of coordinate. Bracket a comma b. Then now we're going to say if I have a vector u in the way a comma b versions, remember that is means if I have xy plane and then my u is sitting or starting from the origin and then go to a terminal point where the terminal point has a comma b, then I can write u in terms of a times I plus b times j. What does that means is I can separating the a comma b and talking about I have a horizontal complement of a and then the vertical complement of b. But what is I and j? I and j are actually two unit vector. I is equal to 1, 0. So what that means is if this is 1 unit and this is I, and j is if this is 1 unit and this is j. So I is 1, 0, j is 0, 1. I is the unit vector for the horizontal direction, and j is the unit vector for the vertical direction. A dot product is talking about another multiplication method. Here we're going to multiply two vectors. So if I have a u is vector a comma b, and then v is the second vector c comma d, then the dot product u dot v. So it's not multiplications because we have so many different multiplications in the vector settings. So we cannot really say u times v. We're not sure which one you're talking about. Are you talking about scalar multiplication, dot multiplication, or cross multiplication? So here we have the dot multiplication, so we say u dot v. So u dot v will be defined as a times c plus b times d. And from the setting you can see the dot product is not going to return a vector. A dot product will return you a scalar. Here is two examples. So example 4, we're going to find dot product for the following. A, we have a vector 2, 3 dot 4, -1. So we're finding the dot product between those two vectors. So to find it, we're going to multiply the a times the c. So a times the c plus b times the d. B times the d. So I got 8 minus 3, which is 5. So you can see the final outcome is a number. For the second one, I have two vectors, 6, 4, and -2, 3, and those two vectors doing dot product. So to multiply it, we got 6 times -2 plus 4 times 3. So we got -12 plus 12 equals to 0. So we got a 0 as the final scalar. So the last part we're going to talk about is the properties of the dot product. Here we're going to using three vectors, u, v, and w, and then a real number k. So we have 6 properties to cover. So the first one is if I finding the dot product between two vectors, u dot v is the same as v dot u. The order doesn't matter. The second one, is if I'm going to do mix operations, I want to add in two vectors, u and v, and then dot it with a third vector, w, is the same as I finding the dot product between the u and w, adding to the dot product between v and w. The next one we have is if I switching the order, if I have u dot addition between a v and w, it follow the same. However, here we're going to have u dot v plus u dot w. Next one we have is going to be a multiplication between vector and scalar. In the earlier section, we're talking about I can multiply any number to a vector. Here, if I have a number k multiplied to a vector u, and then dot it to a vector v, it's the same if I just finding the dot product between the vector u and v, and then multiply the whole vector, the whole thing by k. Or I can go even further to say I can find the scalar multiplication between k and the vector v first, and then dot it to the vector u. Next one, if I have a vector 0 dotted by a vector u, I will get number 0. So just labeling it. The first 0 is a vector because the only situation we can do dot product is between two vectors. And then this last 0, the returning 0, is a number 0. It's a scalar, it's a real number. Okay. Then the last one, the last property is if I have a u dotted with itself is the same as the magnitude of the u square. If u is a comma b, then it's just a squared plus b squared.